just want to do a really quick video. I'm going to follow this video with another one, but I just want to do this really quick video, not to prove this so much, but actually just to go through some of the geography, if you will, some of the mechanism of how to do this stuff. It's pretty straightforward and simple, but it's one of those things, either you know it or you don't, so let's make sure that we know it, shall we? So we just left limit process, and it was really, really arduous. It was a ton of work. This is less arduous. It's less work, but you have to do it correctly, and then you have to figure out how you can put rules together, and that's what we'll do in the next video. So here, there's a series of basic differentiation rules, and the first one is the constant rule, and it says the derivative, which of course is the slope of a constant function, is 0. That is, if c is a real number, then the derivative of that constant is equal to 0. Look, this is all it's saying. It's saying let a constant function be a horizontal line. And isn't it true that the slope of a horizontal line is 0 as I move from, I don't know where, here, if you don't mind, here. So I move from here to here, maybe any 2 points. Isn't it true as I move from this x value to this x value over here, the height doesn't increase at all. Therefore, we have a slope of 0, and that's all that says. And I'm asking you to take that as my proof because, well, it's that straightforward. It's that simple. So, okay, good for me. Secondly is the power rule. And again, this is just the geography and the mechanics of how this rule works. And all it's saying to us is this. It's saying that if, well, let's just do the rule, and then we'll look at how this would work. It says if n is a rational number, then the function f of x equals x, this blue one, to the n power is differentiable. And the derivative of x to the n power is equal to, see this n? This n is this n. And what happened was it came rolling back to here. So this came rolling back to here and was multiplied in this. And then we decremented the exponent by 1. So we decreased the exponent by 1 there. And that's all that we did. So right now we're 2 minutes into a video for which I don't mean to spend much more time on, but let's do this. For f to be differentiable at x equals 0, then n, what n? This n, must be a number such that x, what x? This x, to the n minus 1 is defined on the interval containing 0. And we know defined is that it won't have a domain issue, and we'll talk more about that if you would like to. So just a couple really quick examples. So if we have y is equal to 7, well, y equals 7 would look like this, wouldn't it? Y equals 7, here's the Cartesian plane, and y equals 7, maybe this is this horizontal line here, and this is f of x equals 7. And isn't that true? And of course the slope of this is 0, and that's all. So what you would write here is this. You'd say that dy dx, let me do it a different way if you don't mind. Y prime, the first derivative of y, is equal to 0. Because what does first derivative mean? It means the slope. What's the slope of this function? The slope is 0. So not too difficult, I don't think. And then a couple of the power rule questions might look like this. Say, well, f of x is equal to, I don't know, maybe, let's do x squared. Well then, f prime at x, or the derivative, d dx of x squared, right? So here's x, here's n from the example that we had up here, and all I'm going to do is this, just to show you quickly.